A screencast for the vector homework problems. So hopefully you did well on these, but if not, I want to make sure that I give you verbal answers as well as a PDF. So problem 1 said that a submarine had gone 110 meters at 10 degrees below the horizontal to find the horizontal and vertical components. Well, you need to know your trig. So the opposite side compared to the hypotenuse is the sine function. So vertical side over 110 is equal to sine of 10 degrees. So I rearrange that and get the vertical side all by itself is equal to 110 times sine of 10 degrees. So that vertical component is 19.1 meters. Horizontal would be 110 times the cosine of 10 degrees. I think I mentioned in class that if you think pretty hard and make sure you've got the right trig function for one of the sides, and if that side is a sine, the other side would be cosine. And if that side was a cosine, the other side would be sine if you use almost the exact same type of mathematics. For number 2, someone hit a putt 6 meters to the east, 5.4 meters south was the second putt. It's asked for the resultant. So we used Pythagorean theorem to get 8.07 meters. And this angle, I used inverse tangent because tangent is opposite over adjacent. So to get the angle, we need to use the inverse function. So inverse tangent of 5.4 over 6, and that equals 42 degrees. So my overall resultant, 8.07 meters at 42 degrees south of east. For number 3, I did this a little differently than the group that presented in class. This is similar to the examples I gave you earlier. So I split this up into 4 vectors. One was going all east and no north. One was going 300 south, so I put that as negative 300 meters north and 0 east. This one was going 150 meters at 30 degrees south of west. So I redrew that over here, and I realized that if that's my vector and these are my sides, to get the south part, that's an opposite over hypotenuse, so that would be a sine function. To get the west part, that would be adjacent over hypotenuse, and that would be a cosine function. And so since this is going southwest, but I have my table going north and east, these are both going to be negative. So negative 150 sine of 30 degrees and negative 150 cosine of 30 degrees. For number 4, I did the same thing. This was the angle that was given. It was actually 60 degrees north of west. So since west is not east, I put a negative in front of this. I started screwing up this, so I scratched it out. But the opposite side is what now gives me the north, because the angle is from west. So opposite is the north side, west is the adjacent side. So negative 200 cosine 60 would be a negative 100 meters east, which is basically 100 meters west. And 200 sine of 60 degrees gives me 173.2 meters north. So I add all the north components up, all these components up. I get that this thing's going to the southeast. That hopefully kind of makes sense, because when I look at this, overall, I've got a vector that goes from here down to there. So it is going to the southwest. Hey, that's pretty nice. I didn't know I could do that with a PDF very well. Anyhow, so I put those 2 components together in vector resolution, and I end up getting 201 south, 129.9 west. This angle I can find with inverse tangent, the resultant with Pythagorean theorem. So you see that's something similar to what we did up here. And I get 240 meters as my resultant. You could have either said around 33 degrees west of south or 57 degrees south of west, depending on how you drew this. If you drew it over and then down, the angle would have solved for would have been south of west. 4, super easy. 2 vectors going in the same direction, you add them together. 5 was the hardest one. We talked about that in class. So essentially, if this is going one direction and this is going 35 degrees from it, and all I'm asking for is the magnitude of the resultant, not the exact direction, because I really didn't know the direction of these other than they were 35 degrees apart, I'm going to draw one on an axis so I don't have to do any trigonometry, and then one 35 degrees away. And again, what I'm going to end up doing is getting a resultant that looks something like this. That 15 newtons goes with this line right here. So 28 newtons east. Draw my little triangle down here. The east part is going to be the adjacent side, so that's cosine. And the north part is going to be the opposite side, so that's going to be sine, because sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So once again, if I think about it clearly, if this side is going to be 15 sine of 35 degrees, this would be 15 cosine of 35 degrees. Add up all the north components, add up all these components, Pythagorean theorem, to get the magnitude of my resultant. The reason I didn't need to use an angle there is because this problem only asks for magnitude. For problem 6, we've got a river problem, and so in this particular case, it's 1,360 meters wide. The person is swimming directly across, she's aiming directly across, and there's a current downstream. So therefore, she's going to be pulled downstream, and the resultant is going to be 12.5 meters per second, and this angle opposite over adjacent is going to be inverse tangent, so that's 16.3 degrees. Resultant, it's 12.5 meters per second at 16 degrees downstream or south of east. This is asking about how much time it takes to cross the river. Well, if she's crossing at 12 meters per second and the river is 1,360 meters wide, 1,360 meters divided by however much time would get you that velocity of 12 meters per second. So we rearrange that. 1,360 meters divided by 12 meters per second gets me about 113 seconds. And I said, note, don't divide 1,360 by 12.5, because 12.5 is at the diagonal, 1,300 is horizontal. Those two parts are not in agreement with each other. So to find out how far the person was carried downstream, we multiply the fact that they were carried downstream 3.5 meters for every 1 second they were in the water, multiplied by the time that you had gotten up here. And that's around close to 400 meters downstream. Last problem. This person says they want to end up directly across the river from where they start. Sorry, I double arrowed this. I had initially just drawn it too short. So in order for this swimmer to end up directly across from where she starts, she's got to aim upstream, angle upstream, and so therefore I drew it like this. Should have drawn little arrows at the end of that. Maybe I'll fake it and do it this way, but I'll use black color so that way no one will know that I'm, nope, hold on. No one will know that I'm screwed up. Well, except for the few people who actually listen to this. Ooh, that actually fit nicely. I like it. Yeah, that was good. So therefore, to get this angle, I'm going to use inverse sine, not inverse tangent this time, like I did up here. I'm going to use inverse sine because it's opposite over hypotenuse, not opposite over adjacent. So that's going to be 23.2 degrees upstream that she's got to aim. And this resultant, which is how fast she's actually crossing the river, because she's kind of acting against the current as well as heading across, is going to be less than 9.5 meters per second. So her resultant is 8.73 meters per second due east. I hope these help. I hope it prepares you for your test.